Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be looking at electrochemistry, but now the last bits of electrolysis. And we'll be looking at the applications of electrolysis, and one of the applications is electroplating, as we mentioned in Form 1. So today we are going to look at how electroplating occurs and look at some practice questions. So electroplating is a process of plating a metal onto another by hydrolysis, mostly to prevent corrosion of metal or decorative purposes. So you notice some of the substances, let's say like jewelries, as the ring, the earrings are usually coated with other metals, like for example, gold. We also have other things that are coated with other metal. This coating can happen through electroplating, and electroplating in this case uses electric current. So we are going to see how we use electric current to cause a metal to be plated on another metal. So electroplating is majorly applied to modify the surface features of an object. So electroplating process using an anode and a cathode. The metal dissolves from the anode. So the metal we want to electroplate, let's say you want to electroplate gold on a silver earring, for example. So you put the gold at the anode because we want the gold to get into solution, and then at the cathode what happens is we place the earring in a solution containing gold ions so that the gold can also be discharged at the cathode. So the anode is provided with a direct current oxidizing and dissolving its metal atom in the electrolyte solution. And then at the cathode, the dissolved metal ions are decreased and the metal is placed on the product. So let's, for example, take the case what we are discussing. So we want to coat gold on a silver spoon. So you notice on the anode, this is the anode because it's connected to the positive side of the battery. And when you're labeling, make sure you don't label the battery, make sure you label the anode itself. So the gold goes into solutions and forms the ions, and then since this is a solution containing gold ions, what is going to happen at the cathode is going to be preferred. So the gold ions are going to gain electrons, and then they are going to be deposited as solid now on the silver spoon. So let's look at a few examples and see how that happens. So electroplating a spoon with using copper. So when we do that, let's draw the setup. So we are going to have one beaker. So we are going to have the anode, and this anode will be now the copper anode, and then we have the spoon, which will form the cathode. So this is connected to a battery. So the copper anode will be on the positive side while the spoon will be on the negative side. So this is the cathode, and then this is the anode, and they will be placed in a solution containing copper ions. So this has copper ions. So what happens when we are looking at the reactions that occur at the anode? So the anode, the copper takes part in the reaction. Remember what we said with preferential discharge. Since the copper electrode is not inert, it takes part in the reaction. So it gets discharged to form copper ions, and 2 electrons are given off. So these 2 electrons travel through the wires and they go to the cathode, where now since we have copper ions in solution, so at the cathode, the copper ions in solution gain those 2 electrons to form copper solid. So the copper solid is coated on the top of the spoon. So after some time, we need to keep on introducing more copper electrode when it is depleted, because at the anode it is being depleted and then the spoon is being covered. So as you can see, that is what happens when you're electroplating the spoon using copper. So let's do a few more questions. So one of the use of electrolysis is electroplating as shown below. So we have a key and then we have silver nitrate solution and silver. So to what terminal of the power source is the key connected? So we say that the key will always be connected to the cathode, which is the negative side of the battery, while the silver electrode will be connected to the anode. You can see they have swapped the direction of the anode and cathode, so don't be confused because of that change. It's so intentional. Just remember that whatever you want to coat with is always supposed to be on the cathode, because that's where depositing will happen. So the key is connected to the cathode, or we can say it's connected to the negative terminal, terminal of the battery. So name the most suitable materials for electrode K. We are going to use silver electrodes because we want to control what is going to be deposited. So it is going to be silver. So if we were to look at the actual reaction occurring at the anode, which is a silver anode. So the silver solid goes into solution or is discharged to give silver ions, it's positive, and an electron is given off, which travels. So you can see the direction of the electrons. It travels to the cathode, where the silver ions in solution react again these electrons to form silver solid, now which is deposited on top of the key that you want to coat. Let's look at another one more example. The setup below was used to electroplate a metallic spoon. Study it and answer the questions that follow. So write an equation for the reaction that occurred at the cathode. State and explain what happened at the anode. So first we need to identify the anode and the cathode, which we have been given. So we have anode, which is silver, and then we have the silver nitrate solution and the cathode metallic spoon. So if we were to write the equation, we start with the anode just for the purposes of revision. So the silver solid discharged to get silver ions, because we are losing electrons at the anode, which travel through the wire to the cathode, and on the cathode the silver ions in the silver nitrate gain the electrons lost, because it is preferred to give a silver solid. So if we were to write the ionic equation, this would be our answer, the ionic equation for what occurred at the cathode. And then state and explain what happens at the anode. So we will say silver electrode is discharged to give silver ions, and an electron is given off. Which travels to the cathode through the wires. So the silver electrode is depleted after some time. So basically, the equations that you are writing on the anode, we're just explaining what happens. So the silver goes into the solution or is discharged to form silver ions. So the silver electrode is depleted with time. So that brings us to the end of electroplating. So we're going to look at another application. We are looking at this application separately because they are tested separately, and it is important for us to be able to understand how they work separately. So that's it for today. See you in the next lesson.